Hey folks, we're going to talk about our next part of our unit here, and that is system and graphing inequalities. So in particular, what I'm going to show you here is an introduction to graphing inequalities, okay? Very closely related to graphing our lines, but there's some differences too. So let's get at it and let's talk about what this entails, all right? So here is an equation that we have graphed here, right? And we've been doing this. So graph the equation below, y equals 2x plus 1. And as we can see, this has a y-intercept of 1 from right here. And my slope here is 2, up 2 over 1, up 2 over 1, up 2 over 1, right? And that comes from right here, all right? So piece of cake, we've been doing it. All right, if I wanted to talk about a solution to this equation, I know that I can look at my graph and find that point, -2, -3. Well, let's see, -2, -3. Sure enough, it's on my line, so it is a solution, right? Algebraically, I could plug this in and see if it works. This is my x value, my y value. All right, well, let's see, -3 equals 2 times -2 plus 1. Let's see, does it? -4 plus 1. Sure enough, it does. Okay, we've been there, all right? So that's just a real quick review, all right? So here's another one. All right, graph this equation below. Already done for us. I'm saving us some time by doing this ahead of time. Intercept at -4 and slope of 1/2. So let's see, up 1 over 2, up 1 over 2, up 1 over 2. Sure enough, is 10 -1 a solution to the equation? Well, let's see, 10 -1. That's down there. That's not on my line. Okay, so no, that is not. Okay. All right, here's where we're going to take this to the next level. What if this equal sign here was an inequality symbol, right? This is what we're going to be doing now, right? So if I want to graph the inequality below, so this inequality, it's similar in that the line here is going to be part of it. It plays a very important role. And really what it is it's a boundary for this inequality, okay? All right, because keep in mind, our solutions to this equation were all of these points on this line, right? Anywhere, we could go anywhere. And those y values of these points were equal to, well, whatever this rule was, okay? So, and that put us on the line, right? With an inequality, I don't necessarily need the y values that are equal to the line, so they don't need to be on the line, but in this particular case, and I'm going to erase this so we can see it really well. In this particular case, we need y values that are less than or equal to this calculation, okay? So less than or equal. So not only are all of the points on this line solutions, but all of the y values less than the line are as well. So what I can do is, I'm actually going to make this kind of look ugly, but this is what we do. All of this below the line shows solutions to this inequality. Everything below it, equal to the line, so it could be on the line, or less than the line, below the line. That's how I think of that, okay? So now, same point here, is 10 -1 a solution to the inequality? Well, 10 -1 was here, and it is. Sure enough, it is, because it's in this region, okay? Now I'm going to show you algebraically why that works too. So let's plug it in. Here's my y value, here's my x value, and we're going to see if it works, if it's true. Okay, so y, that's -1, less than or equal to, and I have 1/2 times 10 minus 4, right? Let's find out. -1 less than or equal to 1/2 of 10 is 5, and then minus 4. And -1 less than or equal to 5 minus 4 is 1. -1 is indeed less than 1. So yes, that's true. And sure enough, our graph, because we were in that shaded region, goes along with that too. That's what it looks like to graph an inequality, all right? So let's do another one of these. So here's how it works. I can think of this as a line because that's going to create my boundary. Okay, so y-intercept, right? We can think of mx plus b. So my y-intercept of 6, I'm going to put that on there. And my slope is my m, all right? Now here's one of those cases where you don't see anything there, so it's like a 1 there, so -1. So from this point, I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. And we'll continue that. And I encourage you to put a whole bunch on there. Sometimes even fill up the grid if you can. It's going to make you more accurate. All right, that's enough, I think. And I'm going to draw my line in. Now here's a little tweak already, a little thing we need to look at. You may have noticed that this symbol here, not only is it not an equal sign, but it doesn't even have the equal part of it, right? This inequality is saying we strictly want y values greater than this line we can think of, this boundary. So when I draw my line, what I'm going to do actually is I'm going to do a dashed or a dotted line. Okay, that's going to indicate that, oh, that didn't work very well. That's going to indicate that that's my boundary, but I'm not including the points on that line, right? In this case, I only want points that are greater than that line or above that line, okay? Small detail, but it's an important one. All right, now again, I'm going to make this kind of ugly, but I need to represent all of the points that are above that line, all the y values greater than this boundary that's created, okay? All right, so now when I go to look at solutions, my graph helps me with that quite a bit. Find some points that are solutions to the inequality and some that are not. Well, the ones that are up in here. So like 10, 1, right? 10, oh, no. I don't want to write with that. I don't like that. There we go. All right. 10, 1 is definitely a solution. 0, 11 is a solution, for example. 15, 15 would be a solution. That's way over there. All of those work, right? And if I wanted to, I could check them by plugging these in to my inequality here and testing it, making sure I get a true statement, okay? Similarly, if I want solutions that are, or if I want non-solutions, I need anything here. So like the origin is not a solution. -10, -5 is not a solution, okay? And then particularly in this case, anything on this line is not a solution, right? And that's because we did not include the equal sign here. So I'm going to pick one of those. So let's see, this point right here is supposed to be on my line, and that's 1, 5. Because it's on the line, it is not a solution because it's not greater than this boundary. It's on the boundary, okay? That's how these work, all right? So let's do a couple more. This one we're gonna use Desmos for. Desmos is really powerful, and it will do these, it'll graph these inequalities for us really well too. All right, so let's do this. Y is less than or equal to 3/4 x minus 6. Here we go. Y is less than or equal to 3/4 x. Oh, was it minus 6? Minus 6. Yeah, there we go. So look at that. It graphs the whole thing for us. If this were an equal sign, which we've been doing, we get the line. But because we're doing an inequality, that line becomes a border, a boundary for us. Whoa, no. Less than or equal. There we go. So you'll see the line is still here, but all of this is our solution region for this because any of those points would work in this inequality, okay? So some solutions, right? I need to find those, let's see, all these over here. So like 20, -5, 10, 0, and 0, -10, right? Any of those, I'll write a few of those in if I can remember them. 20, -5. Whoop, no, go back. I think 10, 0 is one I said, and then 0, -10. All right, so you could pick any. There's a whole bunch of them. There's actually infinite solutions here as well. Anything in this region. Okay. All right, let's do one more. Y is greater than -x plus 13. Okay. So y is greater than -x plus 13. All right, so Desmos is nice here as well because it also indicates with a dashed line what our boundary is if we're not including it. And this inequality does not include it. We don't have the equal sign here. Okay, so any of our solutions to this guy are up here in this region. Okay, so anything up there, so like 25, 10, all right, would be one of them. There's a whole bunch of them. All right, so 25, 10. All right, you can pick out a couple more if you want to. Maybe just click pause, find a couple more and throw them in. All right, I'm not going to take another minute here. We're going to move on. All right, so Desmos is super helpful. I encourage you to use Desmos a little while. You need to be able to do this by hand, but you can easily check your work with Desmos, right? But I'm going to whip through a couple of these real quick by hand. All right, so I'm going to graph this inequality. So mx plus b is totally fine to think of it to get started. There's my b or my y-intercept. My slope is 2/3, so up 2 over 3, up 2 over 3, up 2 over 2 over 3. There we go. And I'm going to draw a line in there. Now I'm going to pay attention to my inequality symbol, and it does include the equal sign, so I can do a solid line here. So I'm going to go ahead and do that, like so. All right. So there's my solid line. That's my boundary, and this goes forever both directions. So when I go to identify solutions, oh, I missed something, didn't I? I need to do my shading. Okay. These y values are greater than this boundary line. So I need to go above it. All of these y values up here are greater than this boundary line. Those are all solutions. Okay, now I can find some. Solutions, oh, I don't know, -5, 0, and maybe -10, 10. And let's see, 1, 4, whole bunch of them. All right, you could do some of your own as well if you wanted to. Not solutions, anything over here. So like 5, -5. Okay, or 15, 3. Okay, whole bunch of it. Anything that's not in the shaded region, all right? So 10, -10. Sure, we'll do it that way. Whole bunch. Okay, one more we're gonna do together. I'm gonna graph this one by hand. All right, I wanna think about my boundary as a line. I need to find my y-intercept. There's no b here, all right? Remember what that means? So that's like I could add +0, right? This essentially means that my y-intercept is the origin, okay? Because we're not adding or subtracting anything to the end here. So you can think of it as +0, okay, it goes to the origin. And my slope is 3. So from there, I'm gonna go up 3 over 1, 3 over 1, 3 over 1, up 3 over 1. Continue, and I can backtrack it here too. Totally fine to do that when you're doing it by hand. I actually have a nice fancy line tool that's gonna make it nice and straight for me. So I'm not too concerned. All right, as long as I get it in the right spot. That's better. Okay, and I want to identify solutions, not solutions. Oh, once again, I forgot to shade. Right? You're gonna find that you need to be paying attention to that. And, oh, I made another mistake, didn't I? This does not have the equal sign. All right, so those are a couple details you need to be thinking about with these inequalities. No equal sign, that means that I don't want to include this boundary. So I'm gonna go back and I'm gonna make it dashed. Okay. Now I'm saying this is my boundary, but I'm not including those points. Okay. I'm only gonna include the points that in this case are greater, so above the line. So I'm gonna go ahead and shade. everything above the line. And I missed a tiny bit there, but I think you get the point. Everything over here. Okay, and now I can identify some solutions. So they're going to be over here. So -10, 2. All right, I don't know, a -100. I don't even see it on the graph, but I know it's going to be in this region. So -100, 5. I don't see it, but I know it'll be there. And then maybe 0, 14. Lots of options again. And then again, not solutions, anything over here. So like 15, 0. 5, -5. And once again, I'm going to pick a point that's on this line just to illustrate that that is not a solution. So like this one right here, this is 2, 6. It's on that boundary line, and we are not including that. Okay, so 2, 6 is not a solution. All right, that's how it's done.